Okay, now let's go through our built-in antenna product implementation flowchart. Now, everything is started with with our customer demands. We start by understanding the specific needs of our customer. Then we go to the evaluation stage that takes 4 weeks, where we define the antenna requirements, evaluate system staking and structure, and analyze PCB layout and traces. Then we go to the commissioning stage that takes up to 1 to 3 months. Perform a passive and active commissioning, ensure all indicators and the structure meet the standards, and verify simple proofing. Now we go to the verification and optimization that takes 4 weeks, where we create and verify antenna molds and finalize and seal samples. And the completion stage, where we ensure that the product is ready for deployment. Now let's see our external antenna implementation flowchart. The same, we start with our customer demand, understanding the specific requirements. Now the solution stage that takes 4 weeks, where we define antenna requirements and evaluate the structure, reliability, and performance indicators. The commissioning stage that takes 6 weeks, where we conduct passive and active commissioning and create samples of the antenna. Now the verification phase that takes 6 to 8 weeks, where we verify the design, reliability, and structure, perform final performance checks, create and verify antenna molds, and finalize the seal samples. Now the antenna is ready for deployment. Now let's take a look at our 4G antennas, 4G and GNSS external antennas. The 4G antenna works with a wide range frequency using mobile networks. It has a high gain, strong signal reception, and it's designed to minimize the signal loss. This makes a great choice for improved mobile networks connectivity and ensuring reliable communication. Next is our GNSS antenna. It works with GPS, vedio, and GLONASS system and has a high gain for a strong signal reception. This antenna is perfect for accurate positioning and navigation, making it essential for any application that needs precise location tracking. Now, let's discuss our metering 4G antenna, known for its customizable solution and excellent performance. It is made from durable PCB material, provide a peak of gain of 3.0 dBi, and offers all-around radiation consistent performance. In terms of metrics, the antenna ensures a strong signal transmission and reception across multiple 4G bands, including FDD and TDD. Its customizable design allows it to make it a specific customer requirement, ensuring the optimal performance in diverse environments. Next, we have our narrowband antenna, a small yet powerful device that can be customized to meet specific customer needs. It supports B5 and B8 frequency band, made from durable steel, 4G peak of gain of 2.0 dBi, and provides all-around radiation. This antenna is efficient and reliable across various frequency channels, ideal for integration into smart devices as shown in the picture. Next, we have the Tracker 2G and GNSS antenna, perfect for telematic application. This antenna works with 2G network and GPS. The 2G part is made from a strong steel, and the GPS part is made from a reliable ceramic. It's designed to get a strong signal for both 2G and GPS, and covers all directions. So it's perfect no matter how it's positioning. Our antenna is small and fits easily into tight spaces. We also improve its design to be better than all the older models. Now we have our 4G antenna tracker that utilize LTE Cat 1. We achieve a small dimension to the dimension of this device by customizing the antenna of the casing, as shown in the picture. During the testing, the device performed exceptionally well, passing operators and TRP certification. In terms of performance metrics, the table of the slide can show the TRP performance across various 4G bands. Now, let's explore our range of automotive antennas design for multiple functions and connectivity options. Our GNSS antenna is ideal for precise navigation and location services, featuring a right-hand circular polarization for improved signal reception with an axial radio of less than 4 dB, and an amplifier gain of 28 plus minus 2 dB to boost the signal strength. The 4G antenna provides greater than 3 dBi gain for a strong 4G signal reception, and our AM and FM antennas deliver a reliable performance for radio services. The customizable design allows to easily installation and integration into various vehicle models. The image shows how our vehicle tip box matching antenna is a compact design that can be seamlessly integration without compromising any performance. Now, finally, let's talk about our smart 5G antenna that combines Wi-Fi and GNSS capability and uses a vehicle RF coaxial adapter for seamlessly integration. The Wi-Fi antenna covers both 2.4 and 5 GHz bands with minimal signal loss and a 50 ohms impedance, a standard for high-quality transmission. The vehicle RF coaxial adapter supports cellular bands, Wi-Fi, and GNSS, and is equipped with FACRA connector and low-loss coaxial lines for efficient signal transmission. The shark fin antenna features 4-pin FACRA connector for robust and secure connections. Overall, our smart 5G Thanks.
Thanks, Felix, for your presentation. We have prepared a demonstration to adjust the antenna. So let us have a look.
Welcome to visit Neoway Antenna Laboratory. The equipment we have: antenna OTA chamber, network analyzer, radio communication tester for different wireless technologies, GNSS satellite positioning simulator, 5G radio communication tester. In the following video, we will show you the demo on the passive antenna testing and the active antenna testing. Demo 1. Passive antenna test. Firstly, we use network analyzer to do the initial checking on RF performance. In the marker menu, we configure the minimum marker points and the maximum marker points for each test band's bandwidth, such as the low frequency band, band 8. We input the minimum value of the bandwidth as the marker point 1, and the maximum value of the bandwidth as the marker point 2. Same we configure for other bands like the band 5, band 7. In SWR waveform, we need to tune it as much lower than the mark points as possible to get the best performance. Meanwhile, we can use Smith's figure to check if it needs to add the inductor or capacitor in circuits to improve the RF performance. Once the initial tuning is complete, we assemble the device and place it in antenna OTA chamber to test the frequency, efficiency, max gain, and average gain. Then we will generate the test report. Demo 2. Active antenna test. Generally, we customize the long-length power cable and connect the device to CMW500. As the table in antenna OTA chamber will do rotation during this testing. Once the chamber is closed, we configure the required test bands TRP test item in low, medium, high channels and the TIS parameters. To run the tool and wait for a while, it will generate the test result and the final report. Based on the test report, we can evaluate those parameters can meet the customer requirements or not. Thank you for your watching.
Thanks everyone for your watching. So according to the speaking just now, Neoway antenna team has more than 20 years experiences, and the team has a rich experience on the antenna field, not only for IoT devices, but also the big antenna, such as the base station antenna and the special antennas. We have our own laboratory, and we can provide customers the RF performance testing services. And also, we can give the suggestions to the customer how to optimize the PCBA design. Regarding the RF part, so if you have any requirements or problems, please feel free to contact with us. So if you need today's presentation or video, you can contact with the corresponding sales. Thanks everyone for your joining. Bye-bye.